Hi class, we need to take a look at example 2. Now example 2 on the first problem, for all problems they want us to solve it using a proportion, or in this case just write a proportion. So let me go up and explain what a proportion represents. And all we're talking about on proportions is setting up the problems as two actual fractions equaling each other, where technically your denominators cannot equal to 0. So we're going to have a fraction equaling another fraction, and that's going to be the process of solving some of these problems or applications. You do have to check because some of the problems, the proportions may not be valid, meaning that the fractions are not equal. Now, for the first set, they just want us to write it as a proportion, meaning we're going to end up writing them as A over B is equal to C over D for the quantities. And on the first one, they're saying 4 is to 15. So this is technically 4 divided by 15. This is equal to 36 over 135. Now, this is technically our answer. We do have to check to make sure that the proportion is valid. So notice that if you multiply it on this one times 9 and times 9, it'll work. That's going to give us the 36 over 135. So in this case, this proportion is actually valid. And you do have to do this minor check because the proportions may not be valid. Okay, so let's move on to problem B. And on problem B, same scenario, they want us to set it up as a proportion. So in this case, 12 divided by 5 has to be equal to 96 over the values of 40. This is technically our proportion. And we're always writing them as two fractions equaling each other. And we do have to check. And notice that multiplying times 8 will actually work, and multiplying times 8 will work on this particular one. That's it for B. Let's move on to C. Now, C, the only difference is that you have units. So in this case, I'm just going to rewrite it as 5 wins to 7 games has to be the same as 115 wins over 161 games. So this is the proportion that they're referring to. In this case, let me quickly check it, but we're looking at 23. So multiplying top and bottom by 23, it's what gives the proportion. So multiplying by 23, and give me a minute, let me just double check it. Yeah, we're good. Would be the proportion. It is also possible that for some of the software problems, they're not asking for the units. So in that case, your proportion would be 5 to 7 and 115 to 161. That would be another possibility. That's it for the first problem on example 2, where we're solving proportions. Let's move on to class. I just noticed that it's supposed to be example 3, so I'll fix it on the handout. This is actually example 3, and we're solving these by writing proportions. Okay, let me move on to problem 2. And in problem 2, they want us to solve this particular one by setting up a proportion. And you're given a couple of quantities, and they want how much water. So I'm just gonna declare let X equal to gallons of water. Now for our proportion, we're looking at the following. So 10 gallons leak in 20 hours. So this is going to be 10 gallons 220 hours. This has to be equivalent to technically X gallons in 10 days. Now, before we actually go further, we do have a problem here because your units don't match 20 hours to days. So in this case, it would be more appropriate if we write it as, well, technically days into hours. So in this case, 10 days. And I'm just going to multiply it by 1 day. There's 24 hours. So once you cancel the units, days cancel, and you're looking at 240 hours. So 240 hours. Okay, so let me rewrite the proportion. And in this case, we're rewriting 10 gallons over 20 hours. This is equivalent to X gallons over 240 hours. And at this point, to solve this proportion, let me multiply by 240. So we're just going to multiply by 240. And let me flip it so we have the variable first. So we're looking at X is equal to 240 times the values of 10 over the values of 20. And let me just double check. So 10 times 240 divided by 20. We can cancel one of the tens, and we're looking at 240 divided by 2. So this will be 120. And in this case, X is equal to 120 gallons. So we could write our sentence stating that in 10 days, a total of 120 gallons will leak. From the hose. And that's actually it for this problem. Once again, the main idea is that they want us to set it up as some sort of a proportion, some sort of two fractions equaling each other. And that's it.